This is my Bio 164 lab video project. Today I'm going to be going over the exercise physiology activity. Question 1, Part A asks, as exercise begins, the rate and depth of respiration increases. What is the physiological difference between exercise hyperpnea and pathological hyperventilation as might occur during a panic attack? Well, the difference is in the stimulation. In exercise hyperpnea, movement of the joints and limbs stimulate proprioceptors that send information from the limbs to the central nervous system and communicate to the respiratory control center in the medulla to increase breathing rate and depth. The stimulation of hyperventilation comes from somewhere else. Question 1, Part B asks, cardiac output also increases significantly during exercise. What are two ways the heart can increase cardiac output? Well, cardiac output is given in the equation heart rate times stroke volume. So by increasing either of those two variables, you're going to increase cardiac output. Question 2 asks, look at the baseline data in the table and fill out the rest of it with your predicted changes, increase, decrease, or no change during exercise and recovery. Looking at the table, during exercise, everything except HB saturation, which is your hemoglobin saturation, increases. Hemoglobin saturation decreases. And during recovery, everything is supposed to decrease except for hemoglobin saturation. Hemoglobin saturation actually increases. Question 3 asks, what happens to heart rate, blood pressure, hemoglobin saturation, carbon dioxide clearance, oxygen clearance, and body temperature during an acute bout of exercise? What about during recovery? Why do these changes occur? Question 2 kind of already answers question 3, except for the why do these things occur? The primary reason is to maintain the body's homeostasis. Question 4 asks, compared to a pH of 7.4, hemoglobin at a pH of 7.5 binds oxygen more or less strongly, causing it to release more or less oxygen into the tissues. At a higher pH or a more basic pH, the oxygen is binds to the hemoglobin more strongly and is released less. You can see that data on the graph right here. The actual lines there. The top one is a higher pH. The middle one is the 7.4 pH given to us. And the lowest line corresponds to the lowest pH, which is the most acidic. You can see that O2 saturation is the highest for basic pHs. The basic pH here is 7.6. And O2 saturation is the lowest for acidic pHs. And with the higher binding of oxygen to hemoglobin, there's going to be less oxygen in the tissues. Question 5 asks, what is the control in this experiment? The control is the baseline data given to us. Question 6 asks, an exercising subject has the following measurements. Calculate oxygen consumption and carbon dioxide clearance. Show your work and include the proper units. So, O2 consumption equals 0.209. That's the percent of O2 in the atmosphere, minus the exhaled tidal oxygen, that entire thing times the tidal volume times the respiratory rate. If you plug in your numbers, you're going to get 0.209 minus 0.109 times 2 liters times 20 breaths per minute. And that should give you an oxygen consumption of 4 liters per minute. CO2 consumption is very similar. The formula is equal to the exhaled tidal carbon dioxide times the tidal volume times respiratory rate. Once you plug in all your numbers, you're going to get 0.05 times 2 liters times 20 breaths per minute, and you're going to get a carbon dioxide consumption of, carbon dioxide clearance of 2 liters per minute.